welcome to the channel. My name is Ian and I'll be going through a video that will quickly explain what the differences are between FreeSpeak II, FreeSpeak Edge and Arcadia. I'll also give you a short history on the technologies as well as where their specific pros and cons lie. So to begin, what is FreeSpeak? Well, for many years, Clear Com's wireless intercom portfolio was composed of a number of OEM provided solutions, but the company's own breakthrough in wireless innovation came in 2002 with the first FreeSpeak DEX systems. FreeSpeak was the first system of its kind capable of supporting a high number of simultaneous wireless full duplex users in a license-free multi-area configuration. The system was available as either an integrated wireless solution with the Eclipse Matrix or a standalone system operating on the base station. 2014 saw Clear Com redesign the first generation FreeSpeak system and introduce the 1.9 and 2.4 GHz DEC-based FreeSpeak II product. This was a significant improvement in terms of RF operation, sound quality, and user capability, and has come to be recognized by audio professionals around the world as a standard in mid to large scale wireless deployments. And in 2021, Clear Com updated the FreeSpeak range by releasing the FreeSpeak Edge, a multi-channel, full duplex digital wireless intercom system allowing users to connect to FreeSpeak 1.9, 2.4 and FreeSpeak Edge 5 GHz, as well as third-party Dante devices. Later on that same year, the Arcadia Central Station was released. This is a scalable IP intercom platform integrating FreeSpeak, HelixNet, Dante, 2-wire and 4-wire interfaces, all in a compact 1RU device. So what is it that makes FreeSpeak so unique? Well, FreeSpeak II operates using a cellular network of transceivers located around a working environment. The transceivers connect to the main station, and each transceiver provides an area or cell in which up to 10 full duplex belt packs can operate. Belt packs can roam among and between cells without disconnecting, because each belt pack continually detects which transceiver has the strongest available signal. When the signal from a transceiver starts to diminish due to the distance from the belt pack automatically hands off its next signal to the nearest transceiver, ensuring a smooth transfer. For us to really understand the differences between the different base stations, it's important to understand the differences between the different wireless frequencies. To make things a little easier, I decided to show the US frequency allocation spectrum chart. All countries will have a similar chart, however they may vary a little here and there. As you can see, there's a lot of usable frequencies that have been allocated to various industries, and only a few bands have been allocated for public communication. With this said, we will look at 1.9 GHz. For many years, Clear Com's wireless intercom portfolio was composed of a number of OEM provided solutions, but the breakthrough in wireless innovation was with the first FreeSpeak DECT systems. Digital European Cordless Telecommunications, or DECT for short, is a standard primarily used for creating cordless telephone systems. It originated in Europe, where it is a universal standard, and it operates in a frequency band of 1880 to 1900 MHz, or more commonly known as 1.9 GHz. The next innovation was the use of FHSS, or Frequency Hopping Spread Spectrum. This is a technique that uses a narrowband signal and hops frequencies every 5 milliseconds, and it allowed systems to burn through RF noise and interference that could otherwise be a significant problem. Now, to make this simpler, think of this diagram as a highway moving forward, and the arrow representing your car in peak hour traffic. Now, instead of being confined to just one lane, you start moving from lane to lane to avoid the traffic jam. This is FHSS. Now, both these technologies were used with much success in the original FreeSpeak 1.9 GHz range. However, a worldwide license-free frequency was required to ensure compatibility around the world. 2.4 GHz was the obvious choice, as it allowed users to operate with no license requirements and is specifically designated for transmitting and receiving voice communications. Clear Com uses frequency with their FreeSpeak II systems, and it is a popular frequency choice. However, there is one caveat. It is a very congested frequency spectrum. It's the same frequency spectrum commonly used by Bluetooth, Wi-Fi, baby monitors, RF remotes, and microwave ovens, which means that interference is a very strong possibility. The next license-free frequency band available after 2.4 GHz is 5 GHz, and this will be the new wave moving forward. 5 GHz provides a faster and more directional coverage. However, its coverage is not as far or as wide as the lower frequency spectrums. Faster transmit speeds translates into more channels with better audio quality at lower latencies, but 5 GHz cannot penetrate solid objects such as walls and floors. On the plus side, 5 GHz also tends to have less overcrowding than the 2.4 GHz band, and because it has 23 channels available for devices to use, while the 2.4 GHz band only has 11 channels. Now, as you can see, there are some clear differences between the three frequencies, but to truly understand the pros and cons, we need to dig a little bit deeper into the terminology that's specific to wireless technology. So to begin with, we need to look at available non-overlapping channels. When a station has something to transmit, it must wait for a channel to be clear. Non-overlapping channels are the amount of clear channels available for each frequency spectrum. 1.9 and 5 GHz offers more available channels than 2.4 GHz, which suffers mostly due to the fact that most mobile phones and Wi-Fi routers operate in this spectrum. Next we have total available spectrum. This is closely linked to non-overlapping channels, and is how much data is available per channel. 5 GHz has far more bandwidth available than either 1.9 or 2.4. This increase in data transmission not only translates into more channels, but it also has a higher quality audio with lower latencies. Then we look at outdoor and indoor range. The lower frequency spectrums show their strength here, both outperforming 5 GHz. The lower frequencies are also better at penetrating non-solid surfaces such as wood and drywalling, so will work better in these environments. Multipath and reflection is also a critical criteria. Multipath is reflections that can occur in challenging environments like stadiums, crowded urban spaces, and dome ceilings. When the same signal is received over more than one path, it can create interference and phase shifting of that signal. Digital wireless intercom using the 1.9 and 2.4 GHz spectrums can suffer a great deal from this kind of interference. However, with 5 GHz, those challenges can become opportunities. Reflections, or the multipathing they create, can actually be used in favor of better transmission. And finally, interference by other devices. Interference by devices can happen, most notably in the 2.4 GHz frequency spectrum. One of the main advantages of the 1.9 GHz range is that it does not overlap or interfere with most other electronic devices like Wi-Fi or microwave signals. DECT will have a better range because of this as compared to 2.4 or 5 GHz. However, the 5 GHz frequency spectrum allows for far more channels as there is far more room for non-overlapping channels. This makes it easier to find free channels in the spectrum. So as you can see, there's no perfect frequency spectrum. Whether 1.9 or 2.4 frequencies may struggle, 5 GHz tends to excel, and the exact opposite is true for 1.9 and 2.4 GHz. Now let's look at the belt packs that are used for the individual frequencies. The FS2 BP19 and the FS2 BP24 are almost identical. However, the 24 GHz belt pack is dark blue rather than the grey that is on the 1.9 GHz belt pack. What they do share though is the ability to use up to 5 different channels, and both belt packs can use either the Clear Com BAT60 rechargeable battery or standard AA batteries, and they both use the same AC60 charger, which can charge either 5 belt packs or the separate batteries simultaneously. The FSE BP50, the belt pack used for Freespeak 5 GHz transmission, is the latest generation belt pack, and there are some improvements over the other models. It has a TFT color display with up to 9 programmable buttons. The belt pack also works exclusively at 5 GHz, and because of this has far lower latency. The signal transmits with an AES 256 shared key encryption, and as mentioned in the previous slide, the radio link works well in high multipath or reflective environments. This slide is to discuss where the different products sit in the Clear Com portfolio. It should be noted that the FreeSpeak II is still very much a part of the current FreeSpeak product lineup, and while it's on the lowest tier, it still offers more FreeSpeak wireless channels than the FreeSpeak Edge does. This said, the FreeSpeak Edge is a more up-to-date unit, so although it has less wireless channels, it does include Dante in the design, as well as more 4-wire ports and GPIOs. It also has the ability to connect with the 5 GHz belt packs, something which is not possible using the older FreeSpeak II base. The Arcadia is designated as a central station, as its intention is to become the hub for multiple networks due to its sheer amount of I/O capabilities. It's also the only unit in the 1RU range that can connect HelixNet networks to FreeSpeak Wireless. And we have our final slide where we take a look at the 3 different stations and where their strengths and weaknesses lie. The FreeSpeak II can connect up to 25 1.9 and 2.4 GHz belt packs using the E1 telecommunications standard. It integrates both 2-wire and 4-wire, and it can cater for up to 12 matrix and party line groups or channels. The FreeSpeak Edge is a more modern machine, with the ability to connect to not only 1.9 and 2.4 GHz belt packs, but 5 GHz as well. This can be done via E1 or AES67. Dante is a welcome feature, as well as the extra 4 4-wire ports. The FreeSpeak Edge is limited to 16 wireless or Dante endpoints. However, you can configure up to 100 matrix and party line channels or groups. And finally, the Arcadia Central Station, which incorporates all the features that come with the Freespeak Edge. However, you have the inclusion of both a microphone input as well as a built-in speaker, so the unit can function as a true main station. The Arcadia can be upgraded to 128 endpoints via endpoint upgrade packs, with 40 of these endpoints being available for wireless E1 or AES67 based belt packs. HelixNet is also included and can accommodate up to 24 channels. As with the Freespeak Edge, the Arcadia can accommodate 4 2-wire channels and a further 8 4-wire channels, and can configure up to 100 matrix and party line channels or groups. So that's a wrap up with the Clear Com FreeSpeak II, Freespeak Edge and Arcadia stations. They are all very capable machines in their own right, and you will just need to decide which unit's features is right for your particular needs. And I hope this video has helped you make that choice. If you liked this video, please like and subscribe, and thank you for watching.